Okay, so the area of a region between two curves. So I want you to think about, before we really get into it, I want you to think about the following. Right here. Okay, this is 3. Okay, so let's say this is touching, everything's good there. And we want to find the area here, right? This area. Okay, so if we want to find the red area, how would we do it? Well, we need to find a few different things, okay? And just for simplicity's sake, I'm going to change this to 6. So this is 6, right? So think about this problem and see if you can figure out what the area of that red would be. The area of that red would be. Just think about that for a moment. All right, so take a second, maybe think about it. Hopefully this isn't too bad of a problem. So the big idea is that this is 3, so then this is also 6. And now we can figure out the area of the square. So the area of the square is 36. The area of the circle is 9 pi from pi r squared. So 36 minus 9 pi is the area of the red region, this. So hopefully that makes perfect sense to you. So what I'm going to talk about today is really going to connect to this. So I needed to have this example out before we talk about this. So make sure you have the date down here, right here. And we're doing 6.1 area between two curves. We have f and g continuous on this interval. This is kind of all the calculus talk. And g of x is below f of x, it's less than, so the y value of g is less than the y value of f, and I'll show you what that looks like. And then they're talking about basically what's going on here. So let's just look at that in just one moment. So here's the big idea. You've got basically two functions. So this is a lot of math talk, but you got two functions from 2 points. So from here A to here B. So that's where these functions are starting at. A and B are just x values. We've got one function, g of x, that's a lower function. So I'm just going to make it wavy and lower, and I'm going to call that g. I've got another function, f of x, which is bigger than g, so it must be higher. So I'm going to make f look kind of like this. Okay? So what they're saying to you is that the area of the region between those and these vertical lines, the area of this right here, is the integral of f of x minus the integral of g of x. Top minus bottom. It's almost like a chant that you might want to think about. We'll probably be chanting that in class at some point. Top minus bottom. So if you take this area under f and you think about that for just a moment, f kind of looks something like this, and we say that that area is 12, okay? And then we take this area under g and we say that this area right here, all of this, is equal to 7, right? It's not a grade 7, but you know what I mean. So this area is equal to 7. Well, what would the area of the green be? Well, of course it'd be 5. It only makes sense that it would be. So you're going to be basically taking those two integrals and subtracting them, but you're not going to do the integral of f of x and then the integral of g of x. That would be a lot of work. You're just going to subtract the two functions, and that'll give you the area between. So right here, right now, you should try this problem. It's not too hard. It's just asking you to set up an integral that gives you the area of this region. So they're showing you the two different f of x and g of x. If you want to call this f of x, you can. If you want to call this g of x, you can. Okay? We got to look at which one's on top, so you might want to think about that before you call them f of x and g of x. Maybe they should be switched. And then you should just be able to set up an integral that gives that area. So pause the video, give it a try. Should be a very quick thing. You don't have to solve the integral. All you have to do is set it up. right, so hopefully that went well. And we are just going to kind of go into some examples here and just kind of make it happen. So example 1. Find the area of the region bounded by these two graphs and x equals 0 and x equals 1. So the whole idea is that we have x equals 0 and x equals 1. Those are the two vertical lines. So that's this line right here, and this line, I guess, right here. And that actually ends up going down past the x-axis. And that's bounded by these two graphs. So I'll make it this graph right here. This is it. There's that piece of it. And then this is y equals negative x is this graph. And I'm just looking at those pieces, okay? And we know they extend, obviously. But what are we looking for? We're looking for this almost trapezoid-shaped thing that's in here. Let's kind of look at that with the highlighter. We're looking for this area. Oh, it goes all the way down here. We're looking for this area. So the cool thing is that the algorithm kind of helps us out in that we can simply set up an integral from 0 to 1, the x values, and we just got to do whatever's on top minus whatever's on bottom. Well, which one is on top? The green one, the parabola, the curvy one. So x squared plus 2 is on top, minus bottom, which is negative x. So if you'd like to change, it's plus x. And that's dx. And now all you need to do is solve that integral. So let's go down, let's kind of crank through this solving. Shouldn't be too bad. Then we'll talk about why this worked in this kind of unique situation. I'm going in descending order. We don't need a plus c because we're going to go from 1 to 0. And that's going to give us 1/3 minus 1/2 plus 2. 1/3 is 2 over 6. That's 3 over 6. So that's 2 minus 1/6. That is 1 5/6 for our answer. So that answer should come out to 1 5/6. Take a second and make sure that's right. So give me one moment. Okay, so you know I'm not going to edit this video, but maybe you've caught a mistake. So take a second to see if you can catch my mistake. It's kind of cool to do that. I do have a mistake here. Positive x squared over 2. This should be positive 3 over 6. So that should be 5/6, another 12/6. So this should actually be 17/6 for our answer. So that's our edit. But that's the area of the yellow region. And why does this make any sense? Well, here's the deal. Let's think about it for a moment. We're trying to find the area between two curves, right? So I'm going to try to mimic this picture a little bit, but I'm going to make it a little more blocky, a little more straightforward. So I've got this one area down here, which is like a triangle, let's say. This. Okay. And I've got this other area up here, which is like a, I don't know, we'll call it a, let's make it a block, make it simple enough. Okay, so here's this area. What I really want to know is the whole thing. So we had these boundaries that were the x values from 0 to 1. And we had the function, so this is one of the functions. So this is like our f of x function. And this here is our other function. This is like our g of x function. And we wanted to find out the area of this whole thing, which is the yellow part, right? So we can kind of look at that like in this light. And we want to figure out this whole area right here. Well, let's talk about it. Let's say the green area, okay, is equal to, let's say the green area is equal to, I don't know, 12. Let's say the blue area, okay, well, because that's like the area under a curve, it's actually negative, so let's say that's like equal to like -4, okay? Well then, what is the area between the whole thing? Well, the area in the whole thing has to come out positive. So what's going to happen is we're going to take 12, and we're going to take 4, and we're going to add them. This whole area is going to be 16. And what's happening is, if you think about it, it's like you're minusing a -4, and if you minus a -4, you're adding 4. So that's basically where you want to go with that. So that's the general concept, and we will go on to the next example, see how we're doing on time. Let's take a second. Well, maybe we'll start this a little bit, and then we'll pause the video, and we'll finish it up in the next video. So let's just start this. So we want to find the area of the regions bounded by these graphs, right? And I don't think I should be giving you that graph right off the bat. I think it might be on your notes, but oh well. So you've got these two graphs, and you want to kind of know, like, where do they intersect? Where do they intersect? That's important to know. So what you might need to do is use a couple things. You can graph them if you're really good at graphing. So you could just straight up graph this. It's an upside down parabola that starts up 2. You could graph this as just a line at y equals x. So this one looks pretty graphable in this case. And then you could see where they intersect, but we don't really know where they intersect per se. So how could we find out where they intersect? How do we find where two graphs intersect? Well, we set them equal. We say, when is the height of the red equal to the height of the green? So we set them equal to each other. So we basically just take the 2 minus x squared, and we set it equal to x, and we say, what is the x value that makes that work? So I'm going to just kind of move this over here. So I'm going to have x squared, and move the x squared over, plus x minus 2 equals 0. That means x plus 2, x minus 1 equals 0. So I think that my blue points are x equals negative 2 and x equals 1. You might have been able to get there. I don't know. So this is x equals 1. This is x equals negative 2. That's x equals negative 2, if you can't read it. So that's a huge step towards solving this problem. We'll finish it up. If you want, pause the video and try to finish it up yourself. You're looking to find this area in between these two curves. You might be able to get there because I did the most important step, the newest thing. If not, just wait for the next video and we will do it together. Make sure you do continue on because we need to keep going for this lesson.